In the chapter Factorization, the first part covered Remainder Theorem and questions and answers related to that. The second part was completely based on Factor Theorem. So these two parts we had done. Now let's see the third part of the chapter, in which some questions are solved which are based on the mixture of Remainder Theorem and Factor Theorem. So here we start. Here now you see some more examples are there, and these solutions are a bit lengthier. So let's observe and try to understand. In this example or in this question, the dividend is having two unknowns, small a and small b, apart from x. The first statement of the question says that x plus 1 is a factor of the given polynomial. Hence, according to factor theorem, f of minus 1 is equal to 0. And now you don't need any explanation, you understand how can f of minus 1 be equal to 0. And we simplify this, and at last we get a linear equations in terms of a and b, and that equation is a plus b equal to 8, and that we mark as equation number 1. And exactly the same way, let's see other part of the question. And other part of the question says that x minus 2 is a factor of fx. It means one more factor is there, x minus 2. And again we proceed the same way as we proceeded in case 1, and that is, since x minus 2 is a factor of fx, hence f of minus 2 equal to 0. And again in the function of x, we replace each x with 2, and that is equated with 0 because x minus 2 is a factor, and then this equation is simplified and we get another linear equation in terms of a and b, and that is 2a minus b is equal to minus 5. Now we have two linear equations in terms of a and b. The first one is a plus b is equal to 8, and the second one is 2a minus b is equal to minus 5. Now we take these two simple linear equations in terms of two variables, and we solve it and find out the value of a and b, and many ways are there to solve this simultaneous equation, by adding equation or by subtracting or by eliminating or by substituting. Whatever processes are there, any one of that you follow and find out the value of a and b. So here observe this block where the two equations are added and one value, that is b, is eliminated, and we get the value of a, and that comes 1, and the value of a as 1 we put in any one of the two linear equations, and we get the value of b, and that comes 7. So hence the value of a and b are 1 and 7 respectively. Now the next part of the question is to put the value of a and b back to the polynomial that is being treated as a dividend, and then we find the third factor. Two factors are already known, and the third one we have to find out. Since the dividend is of 3-degree expression, hence 3 linear factors are possible. First two we found out. In fact, first two are given in the question. The third one we have to find out. And for finding out the third one, we need to know the value of a and b, and that we found out, and we put back in the expression, and now we proceed our solution to find the third factor. Well, observe this block in which the value of a and b has been put, and the expression is simplified, and then that simplified expression is x cube plus 2x squared minus 5x minus 6, and now we have to factorize it. Here one advantage is there, that x plus 1 and x minus 2 as two different factors for the given polynomial has already been mentioned in the question. The third one only you have to find out. So here the given expression x cube plus 2x square minus 5x minus 6 is to be divided by x plus 1, so that the quotient we get x square minus x minus 6, and that we factorize, and finally all the three factors we get, out of which the first two, x plus 1 and x minus 2 given, and the third one x plus 3 we obtained here, and this finally is the answer. Or the other way is by splitting all the terms except the first one, as I suggested earlier. That way too you can, or the way you want, you simplify this and try to get all the three factors, out of which first two are given, the third one only to find out. I take one more question here, that is question number 2, and it says using theorem factorize x cube plus 10x squared minus 37x plus 26. This question again is a bit different from the previous one. Here no hints is given. So what we do, we try to put different values of x as is shown here in this box, and this content written in this box suggests that put the value of x as 1 or 2 or 3 and so on, go on checking, so that you get the value of fx 0. It means while putting the value of x as 1, simplify the expression and see what you get, and go on taking different values for x, so that we get the values of expression 0. And the moment we get 0, it means the first factor we got. Here if the value of x as 1 returns the value of the expression 0, it means x minus 1 is a factor. So go on doing that and find out for what value of x the expression returns 0, and then that only we put in the solution, because that will be the part of the solution, and the rest is your rough work. Now finally it's found out that when x is replaced with minus 1, the expression x cube plus 10x squared minus 37x plus 26 is 0. Hence we know f of 1 equal to 0. It means x minus 1 is a factor of fx. Now from the given polynomial x cube plus 10x squared minus 37x plus 26, we extract x minus 1 as a factor. A variety of methods are there of doing that. So follow any one of those methods and extract the factor x minus 1 and observe what quotient you get. And here we find that after extracting x minus 1 as a factor, the quotient is x squared plus 11x minus 26. And as I said earlier, the different processes are there to factorize it or to extract a factor which is known already or given in the question or you found out, and proceed your solution and factorize the expression completely. And here too I say that the expression which is a dividend here is of 3-degree expression, hence 3 linear factors are possible, and finally the result you see, it is x minus 1 multiplied by x minus 2 multiplied by x plus 13, and this is the final answer. But be sure when you write the final answer, that has to be in product form, as it is written here, x minus 1 multiplied by x minus 2 multiplied by x plus 13. Never ever write these values using comma, or never ever try to make it grammatically correct, because the demand is all the factors have to be written in product form. So be careful while writing the last line. Now in try yourself section, a question has been mentioned. You solve this question, and I don't think to complete the chapter you need any more tips. This much only is sufficient, and try your best and complete the chapter. Let's observe another question here. The question says, factorize the polynomial x cubed minus 7x squared plus 14x minus 8 completely using theorem. Well, this polynomial is a 3-degree expression, and we know 3 linear factors are possible, maximum of. So let's try. Towards solution, again we try the same way. We put the value of x as minus 1 and we observe, are we getting the value 0 or not. So this way different value we put, x as 1, minus 1, 2, minus 2, 3, minus 3 and so on, and we try to find out the first case in which the value of the expression we get 0. And we find here that when fx is replaced with 1, the expression results in 0. Hence, according to theorem, we can say that x minus 1 is a factor of fx. We find again the expression returns 0 when the value of x is 2. It means in fx, if x is replaced with 2 and the expression is simplified, again we find the expression results in 0. Hence, according to theorem, since f of 2 equal to 0, therefore x minus 2 is a factor of fx. Again we find that the expression returns 0 if x in the polynomial is replaced with 4. So since f of 4 is equal to 0, then according to theorem, x minus 4 is a factor of fx. Now final conclusion, and that is, we know that the polynomial is a 3-degree expression, and as I said earlier, that maximum of 3 linear factors are possible, and all the 3 factors we found out directly applying factor theorem. Hence the final answer is fx is equal to x minus 1 multiplied by x minus 2 multiplied by x minus 4. And one warning I had given at the beginning, I had said that what answer you get, that must be written in product form, because the question says factorize it completely. So answer must be written in product form only. So here this process is completely different, where at each and every stage I am using factor theorem, but this process is hardly suggested. There are some drawbacks in this solution. Well, what problems are there in this solution? I have mentioned here line by line. So let's go through. Since the polynomial fx is of 3-degree expression, hence 3 linear factors only are possible. The above process is hardly suggested because the process fails if, number 1, any linear factor is found more than once. It means, suppose in the above question, the factors are x minus 1 2 times and the third factor is x minus 4. So here, using above process, we try for the value of x as 1 and we get 0. But how can we understand that x minus 1 2 times as a factor is there and next one is x minus 4? It means for the value of x as 1 we get the expression's value 0, and then for the value of x as 4 we find the value of expression returns 0, and then third value we never get. So this process is not healthy. Another reason, let's see. all the factors might not be in the form x plus minus a. It means if all the factors are there in the form of like x plus 1 or x minus 1 or x plus 2 or x minus 2 and so on, then perhaps the above method is helpful. Otherwise, not. The reason behind is, if suppose one factor in the quotient is there, that is 2x minus 3, it means for the value of x as 3 by 2, the expression returns 0, and that's very tough to guess. So here is the second point that shows that this process is not that helpful. So for the same question, another method has been given here, and this one is a very common method which everyone follows. So let's see that in this what we do. At least once we use factor theorem and we try to find out one factor, and after that the process becomes very easy to proceed and get the answer. In this process, again by trial and error method, we try to put different values of x in the given polynomial so that the expression returns 0. And here we find for the value of x as minus 1, the expression is simplified and we get finally 0. Hence x minus 1 is a factor. Now, from the given polynomial, we try to extract x minus 1, a factor. And here two different methods are given. The first method is division method, in which we divide the given polynomial by x minus 1 and try to obtain the quotient. And here we find the quotient is x squared minus 6x plus 8. And the other method is factorization method, in which all the middle terms we split in parts and the process continues. In this process, minus 7x squared plus 14x, these two middle terms are there, and these two terms we split according to the need. And how to split these middle terms, that has been discussed earlier in this chapter only. So you go back and recall, and here too in short I am explaining that. Let's see that in this polynomial xq is the first term and that will remain as it is. But what next is, we try to find out the partner for xq so that this pair returns x minus 1, a factor, because we know that using factor theorem we have found out one factor, and that is x minus 1. And it is observed that the partner for xq has to be minus x squared. And we can say here that minus 7x squared is splitted in two parts, out of which the first one is minus x squared and the second one is the remaining one out of minus 7x squared, and that is minus 6x squared. Now we try to find out the partner for minus 6x squared such that the pair returns the same factor x minus 1. And again it is observed that the partner for minus 6x squared has to be plus 6x. And now we can say that this plus 6x is obtained by splitting plus 14x. So here plus 14x is splitted in two parts, out of which the first value is plus 6x, which is the partner of minus 6x squared, and the next value out of 14x is plus 8x. I repeat, plus 14x is splitted in two parts. First one is plus 6x, which is the partner for minus 6x squared, and the next one is plus 8x. Now the last value in the expression is minus 8, and we find here that this plus 6x and the last value of the polynomial minus x is a pair which is automatically formed which gives the same factor x minus 1. Now let's observe in the first pair, which is x cube minus x square, we take x square common and it gives a factor x minus 1. I repeat, the first pair, that is x cube minus x square, has common x square and then it leaves a factor x minus 1. Let's observe the second pair, minus 6x square plus 6x. Here minus 6x is taken common and this pair too returns the factor x minus 1. Now we go for the third pair, which is automatically formed. The third pair is 8x minus 8 and here we take plus 8 common and it leaves the same factor x minus 1. Now observe the second last line of this block. It is x square multiplied by x minus 1 minus 6x multiplied by x minus 1 plus 8 multiplied by x minus 1. So from these three terms we take x minus 1 common and the value remains x square minus 6x plus 8. So it's clear that when the given polynomial x cube minus 7x square plus 14x minus 8, when it is divided by x minus 1, the quotient obtained is x square minus 6x plus 8 and no remainder is formed because it was clear that x minus 1 is a factor of the given polynomial. Now we try to factorize the quotient, which is a quadratic expression, that is x square minus 6x minus 8. And this factorization you can perform in a very easy way. It's a very common question on factorization which you have done in lower classes. So here we split the middle term, make two pairs, and finally the answer obtained is x minus 2 multiplied by x minus 4. And finally it is factorized completely and the factors are x minus 1, x minus 2 and x minus 4. But as the question asks factorize it completely, hence the answer has to be written in product form as it is shown on the screen, that is x minus 1 multiplied by x minus 2 multiplied by x minus 4. The last block you observe, try yourself block, where three questions are given, and I hope all these three questions you can solve with full confidence without any hesitation if each and every bit of the class you have prepared very well. The third part of this video on chapter factorization is completed, and now I believe you can take questions one by one from your book and very confidently you can solve all the questions. If you have any query related to the chapter, you can put in the comment box. Thank you.